I had a question about how to work this problem from lesson 1.15. And the first thing I want to suggest is, if you look at the view and example, the textbook very nicely steps through all the different ways that you might solve this problem. So I'm going to suggest to you that's one thing to look at. I also made my own little handout on that particular problem, so let's take a look at my notes here. So it says, find the pattern and use it to list the nth term in the sequence. And here's the numbers that they give us so far. Again, I said the view and example learning aid. It suggests the following steps. So the first thing, approach it in a very systematic way. The first thing it says is the same number added each time. So if I look here, when I go from 32 to 45, I'm adding 13. But then if I try to add 13 to 45, I don't get 60. So I know that this is not the pattern that's happening in this particular sequence. So the next idea is there some multiplication factor? So is this term being multiplied by some number to get this term, and then the same multiplication all the way through? So I tried this on the first couple of sets, and I did it here. I took each subsequent one and divided by the prior one. So 45 over 32 gives me about 1.4. Then if I divide 60 by 45, I get 1.33. Notice the ratio is going down, but it's not the same number being multiplied each time, so that's not going to be the pattern. So the next thing it suggests is, how about looking at factors of the different numbers in the sequence to see if we can see a pattern there. So I went ahead and I factored 32, and that can be factored into 2 times 16 or 4 times 8. Now notice 45 only has one set of factors, 4 times 9, so I'm going to have to stay with that one. So let's look at 60. 60 is 6 times 10. 77 is 7 times 11, and I'm starting to see a pattern there. If you notice, 4 times 8, 5 times 9, 6 times 10, 7 times 11. What's happening? Each time the first factor is increasing by 1, and the second factor is increasing by 1. But I want to get a general expression for the nth term. So let's put this information in a table. And if I notice here, I'm going to list the position that the particular number is in the sequence. So the first number was 32, which is position 1. The second number was 45, which is position 2, etc. And this is what I'm trying to solve for in the problem. So let's take a look at how each of the factors relates to the position number. So for instance here, if this is position number 1, the number 4 is the position number plus 3. And the second number is the position number plus 7. And so I can write that down here. So this is, if this is n, 1 plus 3 is 4, 1 plus 7 is 8. For the second one, 2 plus 3 is 5, 2 plus 7 is 9, 3 plus 3 is 6, 3 plus 7 is 10. So my general term in this sequence is going to be n plus 3 times n plus 7. So let's try it and see. 5 plus 3 is 8, 5 plus 7 is 12, and lo and behold, those are the factors that I had for the fifth term. So this is a very logical way to approach a problem like this, and hopefully this will help you as you're working on this particular set of homework.